Data in a Development World with Andy Roberts.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Before we start, I want to put out a personal message. For those of you who have followed my work and content for some time, you know that I started ClearMeasure 10 years ago. We're a software architecture company, and that's the type of consulting we do to help in-house teams be great, to jumpstart them along their way. So all of our work is programming in all of its various forms, and we've done a tremendous amount of DevOps and cloud automation work as well. And we're the North American consulting partner for Octopus Deploy. Now, I haven't done this very often, but I'm putting out a call for anyone who'd like to work with me. We've been running on a backlog of projects for quite a while now, and we need to grow. We need some more .NET software engineers, DevOps engineers who have Octopus Deploy experience and Microsoft Cloud experience. And we're also in need of a few more experienced software architects. And if you followed me for any length of time, you probably understand how I think about software. And if you like the way I think about it, then you'll absolutely love working with me at ClearMeasure. We need to hire some people pretty immediately. So if this has piqued your attention, please go ahead and apply online on the website. And if you have any questions, just send me an email at Jeffrey, Jeffrey, at clear-measure.com. And thank you for indulging me with the interruption. And here's our regularly scheduled episode. Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and effective, able to deliver world-class results through its ClearMeasure Way methodology. It's a ClearMeasure Way for effective software teams. And a quick announcement, my architecture forums are going strong. Signups for the next month's sessions are up. And if you are a lead architect, if you lead a software team and are looking to collaborate with peer architect leaders, then you can go ahead and sign up at the link in the show notes. And that happens every month. And for those of you who are looking for the Programming with Palermo video podcast, just go ahead and search in any of the directories or on YouTube and you'll be able to find it. Now, my guest today on the show is Andy Roberts. Andy is a data platform and AI architect at Microsoft, where he's worked for over 24 years. A long time ago, his father dropped 2 books on his desk and said, "Andy, I need you to be a SQL expert for a meeting tomorrow. Can you handle that?" And then recently out of college, he was still accustomed to cramming for exams. And so he showed up on the next day. They won the project, and he began his new life as the data guy. And since then, he's been around the block in the data world, whether a developer, DBA, architect, project lead, or more recently part of a sales organization. The heart of his job is always revolved around data, acquiring it, shaping it, moving it, protecting it, using it to predict future outcomes, processing it efficiently, and more. But Andy, welcome to the show. How are you, sir?
Thanks for having me. I'm doing great.
Oh, my pleasure. My pleasure. You've been at Microsoft a long time, before the millennium.
It's been a while. I've actually recently, through the Technology Center, we've had a few college groups come through, and it's always amazing looking out and thinking, "Oh my gosh, they were born after I joined Microsoft."
Yes, exactly. Well, backing up, I want to talk about kind of your experience, and you've done a ton. But do you recall, besides your father dropping that book on your desk, what were some of the big moments earlier in career that kind of steered you down this path into the career that you've had so far?
I'm lucky in that I mentioned my dad. I worked with my dad for a number of years at Microsoft, before Microsoft, and so we have always had computers in the house. So I remember back in first grade, he used to bring home these little AIM 65 little programmable boards I remember I got a TRS 80. I had a Apple 128, a Mac 128 was my first Macintosh. And so I've just always been around it. And he had a company that he ran out of the house when I was in high school. And we did a lot of work in, well, everything on the Mac at the time was in Pascal. So, and then all these libraries were in C++. So I did a lot of work in Pascal, converting Pascal and C++, big Indian, little Indian stuff, and a lot of work in Foxbase. So Foxbase is the precursor to Fox Pro after Microsoft acquired them. And that's really where I got my start in data, was building these little applications around the old Great Plains accounting system, which is now Dynamics, was Dynamics GP. So everything comes back full circle in my life. It's apparently, that's where I got the start. And then just through that, for some reason, always on projects that I would take on that were development projects and whatnot. There's always a data component, and that's kind of just always where I gravitated. Mainly because no one else wanted to do it. I think it's the same reason I was always goalie. No one else wanted to be goalie. I always signed up.
I want to explore that. No one else wanted to do it. What is it that causes some developers to say, I want to write code, but I don't want to mess with the database? Mm-hmm. How would you describe the essence or the forces that kind of divide people?
Mm-hmm. I think that, especially back then, making a mistake in the early phases of a database design could really hinder things, Mm-hmm. And so I think, there's even back then, there was a lot of fluidity and agility in programming that wasn't necessarily there in the data world. Once you had your schema down and once you had data loaded in there, it's very difficult to update that, Mm-hmm. So I think that's one of the reasons why people kind of backed off. I think the other is, this was back when object-oriented programming was really coming to fruition, and so there was always this with the impedance between a relational world and an object-oriented world, and that was always tough for people to navigate. Mm-hmm. And so I found that an interesting problem. So that's why I would jumped in there.
You're right. I think was it around 2006 or so when the SQL Server team came out with the first version of Entity Framework, and Link to SQL had just come out. In Hibernate was like the top open source project at the time. There was a lot of arguing. Now, in your opinion, has that dust settled, or are there still some parts of it that are in flux or still in debate?
I don't think that those are going to settle 100%. And if you look at the influx of NoSQL technologies, for example, a lot of that is to help alleviate some of the pressures that were found from that mismatch, right? Mm-hmm. So that's why Mongo and now Cosmos DB are really, really attractive to developers for a number of reasons. But a big reason is, hey, I've got this object, I'm just going to put it in the database as is. Now, I think when they do that, they find challenges, right? That we solved with relational databases back in the 70s. But now relational databases are taking on non-relational constructs as well, right? So you can store XML types or JSON types inside of SQL Server. Postgres has really good support for JSON objects as well. We've got graph capabilities in SQL Server. So there's a lot of things that are happening in the relational world to make them more NoSQL-like. And then I think you start seeing some NoSQL capabilities, that are saying, hey, why do we have to, live in this world? Why don't we have some of these other semantics? I think of the same thing when I think about big data systems versus like your traditional OLTP systems, right? A lot of times you see you see again like SQL Server looking at Polybase, looking at ways to think about data more holistically than tables and columns. And you see the way that some of the big data systems speed up is indexing, putting things in memory. The things that they were trying to get away from by being big data systems. So I think both sides really push on each other, and that's where innovation happens through the competition.
Yeah, I remember way back the Kindle books on the data warehousing. Kimball. Yep. And early in my career, there was the education on OLTP and OLAP.
Mm-hmm.
And now you have the concepts of big data. But then, like you mentioned, Cosmos DB and document databases. And I think for a lot of developers, the type of data service can kind of mix in with the architectural concept and be confusing. Mm-hmm. So how do you keep that straight in your head? How do you describe it? And not a particular product or a service, but a type of database, and when to know that you need that particular type of data store?
Gosh, that's a really good question. I don't have a great answer. I think there's two things that end up being at play a lot of times. One is the immediate requirements for a customer and a service, and where they think they're going to be going. There's a lot of times where, if you look at what they need in the next 6 months, as I'm putting a design together, I'm going to have this much data, this transaction rate, or this many megabytes per second I need to read from disk, et cetera. But then you look at the different functional areas they're trying to grow in, the different rates of increase that they see in their business, and the big thing is trying to make sure that whatever decisions we make today aren't going to stop them from the growth and the changes they want in the future.
Yeah.
I'm seeing a lot in that, more that microservices design, where each service may not have their own actual data store and instance of SQL or Mongo, et cetera, but being able to make choices at the service or at the product level, and using other technologies like data lake and things like that for aggregating data across all of those services. So I don't think I think this is a long-winded way of answering this question, but I think a lot of it is really having each service design what's important to them, but knowing that there's contracts around how they provide data to other services.
Mm-hmm.
So hey, if I'm going to choose database technology X, but I still need to publish events, for example, for other people to subscribe to. I need to publish APIs to be able to get other services to get that data. And then that gives people the ability to try things out, right?
Yeah.
To test the waters. Hey, is a NoSQL database right for me? What does it feel like to program in that?
Yeah.
It feels a lot different than programming in SQL.
Right. Yeah. I mean, the data world, maybe the data access for programming is different, but there's constantly new services that can store and serve up data. Is it accelerating and I just learned of another one today. Was it Planet something that does MySQL and it like branches a database?
Never heard that one.
Right. But even the Azure services is just so many more are popping up. Some people, why can't the dust just settle on this? I just want to know which ones I have. But and then there's new problems that aren't solved completely. So I guess the innovation is good.
And I think, I guess, back to that point and kind of thinking about it in the microservices world, a lot of times, a lot of customers that come into the technology center are looking to break apart monolithic applications, right? And we talk to them about how you do that. I think we do the same thing at the database level, so it's a lot of the same considerations is breaking things apart, picking the right tools and technologies for that individual service.
Yeah.
But yeah, it's exploded. When I joined Microsoft in 1998. We just released SQL 7. SQL 7 and Access were really and Fox Pro were our data platform. Fast forward to say 2012 or so, and just everything started to explode when SQL 2012 came out. We started dipping our toes into Hadoop. We started supporting traditional competitors inside of Azure, and so all of a sudden to be part of the data team and the sales side in Azure, you had to understand how is Oracle going to run in this environment? When we released Postgres and MySQL and MariaDB as managed services, what does that mean for Microsoft?
Yeah,
and that's been really exciting and sometimes overwhelming, but if you think of it as exciting, then you tend to stick along and stick around and do well. If you think of it as overwhelming and daunting, then it's going to be a tough road.
Right. Another part of your job is AI architect, and of course you got machine learning models with a bunch of data working a different way. But can you break that down? Because you ask 10 different people, what is artificial intelligence? And you get 10 different answers. And then somebody quotes John McCarthy from 1956. And it's like, history. But how does that, what does your job on that front consist of?
So I first of all, the way I think about AI, and there's kind of the broad definitions, but as it applies to what my customers are generally trying to do, it starts with a predictive model, right? So AI kind of starts with a or a set of predictive models, and so predictive model is really a math function, right? F of a whole bunch of inputs equals a probability of something happening or it being something, or because I could have classification, regression, et cetera. So I've got this math function that gets trained a certain way. The math function gets built by using this machine learning process, and there's a couple different ways that happens. But then I have a host for that thing, right? That function, right? And that host could be a bot, it could be a service, it could be something on a web page, giving you personalized recommendations, right? So when you have that predictive function with something to host it, that's kind of where AI happens, right? Or where intelligence starts happening in your application. Now, you take that, and if you think about like, what are all the things that I'm doing? Why am I making predictions, right? I'm making predictions to change behavior. I could be trying to change a system behavior, a user behavior, the behavior of robots, or what have you. But as that behavior changes, the world of my data is going to change as well, right? And so as the data changes, I need to detect that and start retraining that model based on new data. And so that's kind of that self-evolving artificial intelligence, which sounds really scary. But really what that means is that I'm understanding how the world around me is changing, and I'm adapting to that through a series. And that's kind of that ML ops, right? So I know we originally this was about DevOps or data ops, and then ML ops is that component of it where I can retrain, I can measure, I can understand how effective my model is.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
That's a good point. Tell me if I'm getting this right. With machine learning, of course, everybody's talking about GPT, but it always strikes me that the P is pre-trained. So if you have a model that is trained, it knows what you fed into it. Is MLOps in partially taking a stream of events of new data and streaming it into the model for new training every day as new events happen, so that's constantly changing?
Yeah, I mean, you might say that. Let's say I'm looking at the probability that a machine's going to break down today, right? So like in a predictive maintenance use case.
Yeah.
And so I've got a bunch of telemetry coming off of that machine. I've got a bunch of known failures, right? And I can say, hey, given this information that I've seen in the past and the known failures I've seen, here's what I think based on the information I see right now, you should replace this part within the next 6 days, right? So that's kind of the thing you're trying to do. As you get better and better at that, you're actually starting to see the number of failures reduce, right? And so now, how do we start making those predictions? We have to either acquire more data or think about data a different way, or start looking ahead of the problem, in predicting different things instead.
Yeah.
Now, and so as I decide to make that decision, say, hey, I need to acquire more data, or I need to add some new features. Basically that ends up being more of also a data engineering step, but I'm augmenting the data that I'm using to train the model with that new data. but it's not necessarily a stream of new data. It's a big process that kicks off to build that new function.
Mm-hmm.
There are models that don't require that type of pre-training, right? So if you look at, for example, anomaly detection models, right? Those really, I have a stream of data coming in, and it's saying, hey, this point or this set of points looks out of scope or out of compliance with the other data I'm seeing coming in. Doesn't really require training to do that.
Mm.
Or recommendation engines. So usually what I'm doing is I'm saying, hey, here's a set of attributes that I know about Jeff, and here's a set of attributes that I know about these products. I know who's purchased these products, and we can use something called reinforcement learning to say, hey, as people like these items, add them to baskets, buy them, don't return them. Those are all things that I can say, hey, I've got a strong positive response to someone like Jeff buying that object.
Mm-hmm.
Or buying that item.
Yeah.
So that's that requires some setup and configuration, but not necessarily training on data as it's coming through or retraining data.
Right. Just because part of your world is AI, and so many people use it for different things, and just remembering back when I was going through school in the 90s, one of the topics was expert systems, artificial intelligence. And then somewhere along the way, we stopped calling it artificial intelligence, and you just call it expert system, and then the components of you just called it a rules engine. And I think of adaptive cruise control with the radar and the sensing and the brake actuation and accelerator, and it's like, anyway, we just call that adaptive cruise control. So why are we calling some things artificial intelligence and then other things not artificial intelligence, and we give it a different name?
Marketing.
Just marketing. Okay.
I mean, AI has become a marketing term, in my opinion. And that's why you get 100 different answers from 50 different people. Is it just that people will use the term AI to enhance whatever their product is, in my opinion. That's not Microsoft's stance, that's Andy's stance.
Right.
Because I think, that's another story. But so I think that's a big piece of it, is marketing. I think the term AI fell out of favor, right? So there was a lot of, I think, and the same thing with like neural network research, right? Neural networks fell out of favor. I mean, the neural networks aren't new; they've been around since, I want to say, the '60s. But we didn't have the compute to take them further, right?
Yeah.
And so we needed to think about new ways to do things, right? And now we have neural networks that are incredibly large, right? Same thing with AI. There are a lot of failed AI products, a lot of things that AI promised that it wasn't delivered, that we weren't delivering on. So we had to kind of move away from that term in the industry, I think. Now we can do things that are really cool again. So we're calling them AI again. That's my stance.
Okay.
That's my story, and I'm sticking to it.
That makes sense. There's a ton of young people that listen to this podcast because of the massive growth in our industry, just explosive growth. And so, if you were to, knowing what you know now, go back to young Andy, just maybe in the early 20s or whatnot, developing software applications, is there a database or technology or a type of way to store data where you look back and say, you know what, 80% of the time, you're going to need one of these. And then for, high throughput, sometimes in specialized environments, you need different ones. But 80% of the time, you can count on needing one of these types. Does it fall into those categories for you?
I think understanding what third normal form is in a database, and how to, it's when you read through the research papers on it, it sounds really daunting, but there's a few basic rules, right? Understand those rules and start and think through that, when you first start putting data into a database. That would be one thing. And then know that when you want to do something that's more at scale, like large scale reporting, that's not the schema to use, and to use it more of a kind of that star schema that we talk about in data warehousing. And just understanding kind of the difference between those two, and why one is purpose built for one task and the other one's purpose built for another, I think is really important.
So what I'm hearing is you're going to need relational data. Just count on it.
I think for the foreseeable future, new folks writing software that's in the underpinnings of a lot of what people are doing.
Yeah, that's what I've seen too. But you've gone way deeper in data than I probably ever will.
Yeah.
It always seems like, yeah, I mean, even if you have other things that pop up, you kind of need relational data. It's almost like that's the core, it seems.
Yeah. Yeah. I mean, even if you look at, like, let's say I've got a NoSQL database, like a Mongo or a Cosmos, and I'm using that to back end my order processing system for a large e-commerce retailer. Say, when I start saying, hey, I want to do, I want to close the books, right? And I need to move this into my accounting system and see what my end of year balances are, and look at year over year analysis, and then start doing reporting on that. That's not something that a NoSQL database is really good at.
Yeah.
There's aggregations, there's ways that we can do these things, but so even if you're using NoSQL for your OLTP, you probably need something relational or big data like on the back end, which and then building some relational constructs on top of that big data, tabular constructs.
Yeah, and it seems like because of the long tenure, multiple decades, everything knows how to integrate and tap into the SQL Server engine and pull out and then build charts, graphs, and every kind of visualization under the sun.
Yeah. It is that common denominator, right? Everything, there's everything that can talk to an ODBC driver, which is most things, can talk to SQL, and understand most of the time you're displaying data, you're thinking about data, you're thinking about it in rows and columns in some way, shape, or form. Now, I don't know if that's because we've always had relational databases, so that's the way we think. But even before databases, if you have like double entry bookkeeping, that's still rows and columns, right?
Right.
General ledger was built that way, before there were computers, right?
Right.
So I guess maybe it's a human thing. I was trying to think: is this a human influencing computers, or computers influencing humans? But that's a common thing. I say, with, for example, blob storage in Azure, right? If you're undecided on, are you going to use Synapse or Databricks or some other engine, or something, my own Spark engine hosted in Kubernetes, or whatever you're going to do, but you're trying to accumulate all this data, put it in blob storage, right? The reason I say that, and then we call it a data lake, right? And the reason I say that is because pretty much everything knows how to connect to blob storage, So it's the same thought process. Look for those common denominators that everything can talk to. That, and then you can kind of delay and defer some of the decisions as you're playing around with it and making up your mind.
That's a good point. I see. I use a network attached storage from Synology for photos, and then also I see iOS doing this for photos. I see Google doing this for photos. Where for years it was just, I got a bunch of photos, and then all of a sudden there popped up, hey, would you like to see all the photos you took in this city? Would you like to see all the photos you took on this date range? I'm like, yeah, because they were just blobs, but then they went and mined all the metadata at some point.
Yeah, or where it starts getting a little scary is most of my photos just get synced up, and I don't really do anything with them, right? Some of them, maybe I tag them, right? I say, hey, this is a photo of my kids.
Yeah,
this is Max, and then 2 years later, it says, hey, do you want to see all the photos you took of Max?
Facial
recognition. Photos that I never have tagged.
That's right. That's right.
Yeah.
Yeah, because it's identifying the faces.
Yep.
And that's useful. And you're like, yeah, that's useful. That's also creepy.
It is.
So you mentioned data lake. I really love that analogy. Hey, you throw it in blob storage. That's a data lake. Is that all a data lake is? How do you break down that concept to describe what a data lake is and how you should use it?
I'd say I oversimplified that a little bit.
Which is good. We need that.
But the underpinnings in Azure, when I think of a data lake, the first thing that with the resource that I deploy to Azure is a blob storage account. And it could be multiple blob storage accounts, when the physical design happens, but there's a checkbox on the blob storage account that says use hierarchical namespaces. Now this, you probably don't check it because I have no idea what that does. When you check that checkbox, that does a couple things to the blob storage account. One is, instead of, let's say I've got millions of files in there, and I have a folder structure. Like, as you know, in a blob storage account, traditionally, if I want to look for a file name, like the folder names are just a naming construct. It doesn't actually have any real meaning. It's just an object in a store. With the hierarchical namespaces, it's actually indexed appropriately, so that if I look for files in a folder for this date, it's not scanning the 100 million files. It's looking for those 50, and it knows how to find them because it's indexed appropriately. It also lets me do things like access control lists and other things that are really important when you start putting a big data system together. And then the other piece of it at the storage level is really around ingesting that raw data. So we ingest raw data kind of as is without transforming it, without changing the schema. And then we talk about cleansing and curating the data in different, we call zones in the data lake. And so there's the kind of the storage mechanism, and then the organization of that data, and then the processes you put on top of that.
Yeah. Well, so dialing back all the way to, you're always going to need relational data. If a piece of software that's going to be built has 12 users, is there really a lot of analysis that someone has to do and what the data size should be, or will almost anything work at the lower scale? Can you get into trouble?
The reason you get in trouble is because you release that piece of code that has 12 users, and then tomorrow it has 120 users. That I actually spent 2 years working with a customer on an application that was it was a VB ASP app back then.
Yeah, late 90s.
That was a prototype that said, "Hey, this is what this app could look like." And the CEO of this company said, "Great, ship it."
Yeah.
And so 15 years later, they brought me and a team in to say, "This thing's not performing so well."
Right.
The lead developer of the prototype is going, "I told them not to put it in production 15 years ago." And so you always have to think about where this is going to end up, not where it's starting.
Yeah. I also think of systems like Django that kind of give you a default database structure and just start putting data in places. And it works initially, helps you get something going. But if you don't think about the schema, then you never know what's going to go.
Yep. There are, if you look at the Power Platform side of things, we've got Dataverse now, right? Now, what's interesting, Dataverse is essentially backed by SQL, right, behind the scenes. But and you can actually connect to it with a SQL endpoint, and just like any other application. But I think that's an interesting framework, right? So it's still you've got a lot of stuff for free. You've got a pretty easy way to define new entities and attributes that make more sense, I think, to a business user. And sometimes, not all the times. But it's a little bit safer on the back end, I think, than some of the other frameworks that I've seen.
Yeah. Well, as we close up here, you've been kind of at this for so long. You probably used every tool under the sun from Microsoft, from Redgate, from every different place. Are there some tools where, for those who just may not even be aware of all the great tools out there, where you would say, hey, go check these out. You need to be aware that these are out there because they're just really good, tools, Microsoft, third-party commercial, whatever they may be.
Redgate's a great call out. I used to, when I was more on the developer side, I'm actually writing code. I use them extensively for, data comparisons and data generation and things of that nature. I think that one of the big shifts over the past 25 years is and this kind of goes back into what we were talking about earlier, is really thinking about the database as part of the application, not a separate thing, right? And I think Redgate actually really led the charge in starting to think about kind of like the DevOps side of data before there was something called DevOps, But the work that's being done with like GitHub Actions and Azure DevOps pipelines for keeping a database schema up to date and in lockstep with an application code base that's really accelerated, I think, in the past few years, and so that would be something that I would call out.
Okay, awesome. Yeah, it's always good if you're not aware that something's even exists out there. You don't know to look.
Yep.
Awesome. Well, hey, this has been a tremendous time. We could probably talk for several hours just digging into all these, but as we're kind of closing this up, for young people looking to make a career out of data, is there any one or two pieces of advice that you would give?
Number one, keep at it and keep smiling. It can be a frustrating world sometimes in the data space, as you might be looking at application and development challenges differently than some of the team that you're working with. But the other is, I would say, the most successful and the most fun I've had writing software for and with my customers has been when it's not necessarily a distinction. The data developer is a developer, and the developer is a data developer. I might have more responsibility and oversight over the database tier, but everybody's doing that work, and we have shared responsibility. So if you're a UI person, understand how the data is being stored. If you're a data person, understand how the UI is done. I say that, and I'm not a UI person by any stretch of the imagination, but I try to understand how it works at least.
Right. Yeah, it's one thing to make a button do something. It's another to make it beautiful.
Exactly.
Well, awesome. That's good. That's good advice. Well, Andy, thank you so much for coming on the Azure DevOps podcast and sharing so much about the data tools and how you think about data and all the different databases and patterns and where it fits into artificial intelligence. Just a lot of great information there. Thank you so much.
Oh, my pleasure. Thank you very much for having me.
Oh, happy to have you. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.